Hi there. How are you?
Hi. Did you finish Ariel's homework?
What? Oh, right, I totally forgot about it. I was so focused playing video games last night that I didn't investigate anything about programming languages.
Well, it took me one whole week to finish my research about Chapel.
Wow.
For example, did you know that Chapel is an emerging parallel programming language developed and designed by Cray Incorporated? One important aspect of Chapel is that it was designed to improve the productivity of end users and to be a portable model of a parallel programming language used in clusters. Unlike OpenMP that creates heavyweight threads into task sharing scheme, Chapel uses subcomputations that can be executed concurrently. Now talking about the four key principles of Chapel. One being general parallel programming, while the other are locality-aware programming, object-oriented programming, and the last one generic programming. Let me explain you each one of the principles. First, Chapel supports general parallel programming through the use of high-level language abstractions. It also features global view data structures, which are arrays and other data aggregates that have sizes and indexes globally expressed, although their implementation is distributed across the locales of the parallel system. Do you have any idea of what a locale is?
No. Does that word even exist? What is it?
Well, a locale is an abstraction of a unit of uniform memory of a certain architecture. Within a locale, all the threads show similar access times to any memory direction. This view contrasts with the majority of the parallel programming languages as the users are the ones responsible for the data partition by doing it manually or with abstractions. On the other hand, we have the global control view in which the program of the user starts its execution in one single logical thread of control, and then the parallelism takes place through the use of certain concepts of the language. All the parallelism in Chapel is implemented with multithreading. These threads are created thanks to the high-level concepts of the language and are managed by the compiler in runtime, instead of using the typical fork join process. In the third principle, we have object-oriented programming, which has been a key element in order to increment the productivity of programmers, thanks to the encapsulation of certain related information and functions within a single software component. It also supports specialization and reuse as a mechanism for defining and implementing interfaces. It is not necessary that the programmer adopt a new style in order to use Chapel, because the capacity of its libraries are implemented using objects. With this, the programmer only needs to know how to invoke a method. Finally, the fourth principle gives Chapel that capacity to handle generic programming and polymorphism. This characteristic permits to write code in a generic style across the types, making it useful for many variable types, sizes, and precisions. The reuse of code allows to express algorithms without being explicit, replicated for each possible type.
Yow!